discussing a paper out of Datology AI, which we came across after listening to an interview with Ari Morcos, the CEO of the company and founder. Very interesting company, very interesting problem that they solve. The problem that they solve is, in essence, what is the optimal amount of data to achieve a certain performance grade for an AI model? Or another way to formulate the problem is, what is the incremental information value of data that helps me get a better model? I think this is a key metric that, as Ari actually says in the interview, links are in the show notes, by the way, the paper and the interview he gave with No Priors. Shout out to No Priors. So he says that the fundamental question is, what is the incremental value of a certain data point? And data pruning is the art and science of reducing a data set to the optimal size for training. So what that does, of course, it lowers cost, it increases speed. As he says, the mission of the company is to increase speed, lower cost, and also increase performance. Now, performance can be increased with various ways. For example, diversity, size, scale. The bitter lesson says that just as much data as possible, as diverse as possible, and only limit is compute. Now, what Datology is trying to do is say, look, there are ways to improve the performance of models without just going full-blown, billion-dollar investments, and that is, we can be a little bit smarter about data. Now, I'm working on a larger sort of piece. I'm not sure, it's probably going to be an essay. It's definitely going to be also several episodes of discussion about the ideas of Richard Sutton, and then Jack Parker Holder, and also Marcus Hott. The idea of self-learning systems, of automated reinforcement learning. I think these things are they're somewhat related, because what Ari and his company are trying to do is trying to find the optimal data for a specific problem. Now, I think that they're running up against a bitter lesson here, because eventually we want the models themselves to not just learn what kind of problems to solve and adapt to the environment, but also ask the right questions. In other words, predict what data might be useful for it to learn specific problems, or to use the oak architecture nomenclature, what features, once it decides to learn certain features, it also decides to accumulate the kinds of data that are necessary to learn the features. So in other words, we believe that this can be automated as well. Now, of course, like many things in AI, it might start with human annotation, human pruning, human input, and then eventually automate itself. I think what I want to say, though, and the reason I really like this interview is Ari he seems like a very interesting guy in general. He says that he says two important things. One is the amount of investment that is going into data management, data pruning, data optimization is actually much smaller than the amount of investment that frontier model providers are, spending on actual model performance and data collection in general. Optimizing data is sort of a low-hanging fruit. But he says something else which really turned on the light bulb with me, which was that they actually used human professional AI researchers to predict what kind of data pruning and what kind of data selection strategy the humans would choose relative to an automated model that chooses and prunes data automatically. And there was an experiment that was made, at Stanford. So there was a couple of dozens of people, Stanford and other universities, worked on a data optimization model, and the task was now these professionals were supposed to predict also what kind of data optimization strategies the model would do. And the interesting thing is that most humans were totally wrong. In other words, it was virtually impossible to predict what kind of data strategy the model will choose. And the reason is because the optimal data for a certain model given a certain task is often a function of the relationships that prior data and maybe also potential availability of data has with the actual next incremental data. In other words, it's not just the actual data point that is coming next and you make a decision, should I include it or not. It's the relationship of that data point with the prior data and potentially also with what's predicted, which is what's coming in the future. So it's a lot more complex. That's what I'm trying to say. And we believe here in Orange Capital Partners, and I think Ari agrees with that, is that eventually the data selection strategy and data pruning strategy will be also an unsupervised learning methodology, like most other advanced models, and we will not have to incorporate any priors. Another thing that he said, which I think is really important, which is that he says the biggest breakthrough actually was not necessarily the transformer architecture. It was the ability to learn from unsupervised learning, which goes back to a prior episode we just had, which is if you want to understand NVIDIA, learn linear algebra. I think linear algebra and the ability to understand, mathematically, structurally how data relates to each other is at the core of what NVIDIA is doing, at the core of what AI is doing, and fundamentally also at the core of advancements in AI, because this is how unsupervised learning will continue. And I think the fact with unsupervised learning is the really amazing thing about it is that we can, with unsupervised learning, we have this uncanny ability to basically learn from an unlimited amount of data. We can also instruct the models to not just learn from data by themselves, but also choose the kinds of data that they might want to learn from. And in the future, also create the synthetic data. This is the many worlds interpretation of AI that we spoke about. In other words, create create world models based on Gen AI, and then choose trajectories that are most likely going to lead to a better solution. So to summarize, I think this datology idea, this whole concept of optimizing data, pruning data, I think it's a massive, massive theme. It's really interesting. It's a big research project. It's not solved by any means. The reason we bring it up here is, first, it's very inspiring. I think Ari said a few really interesting things. One is that data optimization and pruning is underinvested. Second, that most likely it's going to be the bitter lesson here too. And third, that unsupervised learning is actually the big breakthrough. And that goes back to linear algebra and what NVIDIA has been able to do to parallelize all these computations, because when you do unsupervised learning, your compute starts going up. Thank you.